Trigonometric identities. This first example says, write the following expression in terms of sines and cosines or cosines and simplify or. Okay, so I'm going to just rewrite this a little bit neater. So this would actually look like 8 plus cosine of alpha times tangent of alpha cosecant of alpha, all divided by cosecant of alpha. Okay, so as a reminder, we know that tangent of alpha is equal to sine of alpha divided by cosine of alpha. Cotangent of alpha is cosine over sine. Our secant is going to be 1 over cosine. And cosecant is going to be 1 over sine. So it's just a real quick refresher. So knowing this, I can rewrite certain parts of this and get it in a format that works for me. I got cosine here. So let's rewrite tangent and cosecant. So tangent is sine over cosine. Cosecant, we just said, is going to be 1 over sine. And then cosecant, 1 over sine. All right. Now that I got it written like that, I'm going to do an extra step. I just want to rewrite it in a format that I understand. So I got cosine. I'm going to put it over 1, and it's going to be times this sine over cosine times this 1 over sine. And I am going to say it's going to be all times. So I'm going to bring this out, and I'm going to use that key. Well, I'm going to just, you know what? I'm not going to skip that step. For those that are a visual person, I'm going to do one more step. All right. Going to keep, change, flip. All right. Now, I have it written this way. Now, in order to do anything else to it, I need to take this and distribute it to everything. So when I do that, now I have 8 sine plus, I'm going to distribute this to the inside of that parenthesis. So when I do that, now I have cosine alpha, sine alpha, times 1 sine alpha all over cosine alpha sine alpha. Right? So it looks good. So what do I see here? Well, I notice that I can reduce this cosine with this cosine. I can reduce this sine with this sine. And I'm left with sine times 1. Let me scroll down a little bit, give myself some more room. So now this is equal to 8 sine alpha plus sine alpha. And since they're like terms, and what do I mean like terms? They're both sine alphas and they both have the same power. So I'm going to say 8 sine plus 1 sine gives me 9 sine alpha. And that's my answer. Okay, let's do our next one. It says find the product and simplify your answer. Well, if you notice, I have 2 parentheses. They're being multiplied together, and they have the same first term, the same last term, but the signs are different. So if you wanted to use a shortcut method, I'm going to write that formula over here. But if you don't want to do that, I wouldn't do it. So if the first terms are the same and the last terms are the same, but the signs here are different, then that means I'm just going to square the first minus square the last. and then we're done. So if you want to use that method, you can. But if not, what we could say is, okay, I'm going to distribute or use the full method. So I got secant times secant x. So I get a square, right? It's the same as saying x times x. You get the x squared. Okay. So just a little refresher. All right. Now I'm going to say this first term times this last. So I get a secant x times positive 1. So I get a, and they're both positive. So I get a positive secant x. Let's do the next one. So now I'm going to grab this negative 1 and multiply it to that secant. So I got negative 1 times positive secant gives me a negative secant x. And let's multiply this last term in that one and the last term in that one. So I got negative times a positive, which is negative. 1 times 1 is 1. What happens to this part here? It goes to 0. Now I'm left with secant squared x minus 1. So if we go to our identity rules that we got, we know that our Pythagorean theorems for this trig, we know this. I'm just going to write it down as a refresher for you. So if I was to solve for that cosine squared, this is what I'd get. You could solve for the sine, and you solve for the sine, then you would have got. So these go together, right? Then we have 1 plus cotangent squared x is equal to secant squared x. We've got 1 plus tangent x is equal to secant squared x. All right, so what if I solve for tangent here? That means I'm going to subtract that 1 from both sides. And what do we have? We have tangent is equal to this. So my answer here is going to be tangent x, because this is simplified form. You should always simplify it down. Oh, I left a square off, guys. Don't forget to get the square. Oh, good catch. Okay. Let's go to our next one. Okay, so our next one says we're going to prove that the following equation is an identity. I'm going to rewrite it where it's just a little bit easier to read. This should have been a lowercase s, not a capital. And divided by tangent x is minus tangent x over secant x is equal to cosine x cotangent x. So you want to pick one side of the equal sign and solve for it and see if it equals the other side. And if so, then you know you have an identity going on here. So you can pick which side you want. However, I want to do this side here. So when I look at this side here, I see that I have fractions minus a fraction, but the denominators are not the same. So I'm going to multiply top and bottom by whatever it takes to get the same denominator or like denominator. So, because remember, whatever you do to the bottom, you have to do to the top. So now I can rewrite this. I got secant times secant, so it's secant squared x, minus tangent times tangent, that's tangent squared x, and it's all divided by the secant x tangent x. Or you could have wrote the tangent first. I mean, multiplication, just a quick reminder, 2 times 3 is 6, 3 times 2 is 6. So in multiplication, that order right there doesn't matter as far as that goes. All right, so we're almost done. Now let's clean this up a little bit. We go back to that identity of 1 plus tangent squared x is equal to secant squared x. Well, if I subtract the tangent from both sides, I'm going to have it all equal to 1. So I got 1 is equal to secant squared x minus tangent squared x. That means my numerator here is 1, right? And that leaves me with secant x tangent x. So we're almost done. What do I know about 1 over secant x? Well, I know that 1 over secant x gives me my cosine, right? Because remember, secant is the inverse of cosine. So that gives me cosine. Check. tangent is going to be 1 over, tangent. I know cotangent. I was like, wait a minute, what did I do? Cotangent is 1 over tangent x. So then that tells me that this 1 over tangent gives me my cotangent. So we have an identity here. Okay, let's go to our next one and see what we got next. All right, it says find the exact value of the expression using the half angles identities. All right, so we can go back to that section and get our half angle identity. It's cosine x halves equal plus or minus square root of 1 plus cosine x divided by 2. And the reason I chose cosine is because it gave us cosine of 105 degrees. So what we need to do now is we got to figure out what is x, right? Well, I know that, and what I mean by x, look right here. We gotta clean this part up first. So I'm gonna take the 105 degrees, set it equal to x over 2, solve for x. That means I need to multiply both sides by 2 to undo that fraction. So now I have x is equal to 210 degrees. We're good. So I'm gonna take this cosine of 105 degrees. We know that's gonna give me back cosine of 210 degrees divided by 2. That makes sense, right? Because 210 divided by 2 gives me back what we started with. So we didn't change the actual value or expression that was given to us. We just made it more workable. So now it's going to equal plus or minus the square root of 1 plus cosine of 210 degrees divided by 2. So I'm going to clean it up. Bring that down. Okay, clean it up and get plus or minus. Well, cosine of 210 degrees is going to be a negative square root of 3 halves. Divide that by 2. We're going to do a little bit of math, basic math, to clean this up. I'm going to give myself some more room. So I have 1, and this positive times negative gives me a negative. So I'm going to go ahead and put a negative here. And then I'll have the square root of 3 halves, and it's all divided by the 2. But in order for me to subtract this numerator here, I need to have a common term, or common denominator, and the common denominator here is 2. So I'm going to multiply this by 2 over 2, so I can get it in the format I need it. I went a little too far on this bracket here. Let's see, let's rewrite it. Okay, this is equal to plus or minus. I got 2 minus square root of 3 over 2, all divided by 2. I'm going to rewrite it. I'm going to do some basic math. So I got 2 minus square root of 3 over 2 divided by 2. Of course, we're going to keep change flip. Keep the first, change the operation, flip the second. We're almost done with this one. So now I got plus or minus 2 minus square root of 3, and the denominator is 2 times 2, which is 4. I'm going to rewrite it. So now I got plus or minus, and square root of 4 is 2. So now I have my answer. I cannot clean this up anymore, except for we need to determine which one we keep, plus or minus. So this is how I know. We go back to the unit circle, right? And we look at where does my x value fall? Well, I know that at 200 cosine, I say x value because cosine in our order pair in algebra represents the x value. The cosine of 210 degrees falls in this quadrant, right? 105 degrees falls in this quadrant, but we're looking at the cosine at 210 degrees. Cosine is negative in this quadrant. It's even negative in that second one, but it's negative in the third quadrant. Therefore, my answer here is going to be a negative value. So this is my answer. Okay, that ends that section.